So now that we've finished talking about the image stream gang case study and we've talked about the various categories of completable future methods, it's time to take a step back and evaluate the pros and cons of the Java completable futures framework. Because we want to be optimists, we're going to start out by talking about the pros. And to do this evaluation in a representative way, we're going to really compare and contrast the use of completable futures relative to alternative ways of doing parallel processing in modern Java, namely using parallel streams. And we'll use the image stream gang case study that we've now explored from a couple different perspectives to help make this very concrete and tangible. So one of the nice things about completable futures is that they simplify the programming of asynchronous operations. And keep in mind what a completable future does. It supports dependent actions that trigger upon the completion of asynchronous operations. And what's cool about the completable futures framework, thing that makes it much more powerful than, say, vanilla Java futures from back in the day, 15 years ago when they came out, is these asynchronous operations can be forked, chained, and joined together in a relatively intuitive way. And what do I mean by that? Well, basically, because of the fact that we have these completion stage methods, we can make asynchronous programs look and feel or appear quite a bit like synchronous programs. And that's really cool because we all know how to reason about synchronous programs pretty well. It's the asynchronous programs that are hard to reason about. And so by using the completable futures framework, and particularly the completion stage methods, we can make the programming look synchronous even though things are running in the background by chaining together these various completion stage methods. Something else you can do with the completable futures framework is you can have asynchronous operations run in parallel in different types of thread pools. And these can either be the common fork join pool, they can be a custom fork join pool, they can be some other type of either predefined thread pool like a cached thread pool or a fixed size thread pool. You can even go ahead and define your own user-defined thread pools if you want some other way of running things in an asynchronous, parallel, or concurrent way. Something else that's really nice, and this kind of mirrors what we talked about with parallel streams, there's no need for explicit synchronization often. There's no need for explicit threading often, and therefore you can let the completable futures framework handle all those details under the hood for you. By the way, that was a common mistake in the frequently made mistakes I put out for your assignment 3. A lot of people, for some strange reason, were explicitly spawning a thread and then using completable futures in that context. No need to do that. You should be using the supply async factor method, not creating your own native Java threads. One of the ways that this works well is that Java and the Java class library handles the various synchronization needs, either by baking those things directly into various classes like IO classes, which are carefully designed to avoid race conditions when accessing the content of the file system, or by using various Java concurrent collections like concurrent hash map and so on. So there's lots of things you can do to avoid having to do synchronization in your code. Now, as we saw, completable futures are a bit more complicated to program than, say, parallel streams. So there's got to be a reason for using them. And the main reason for using them is that they're often more efficient and more scalable. And you can see here that if you were to run the image stream gang program and compare it in apples to apples mode, where it compares the performance of the sequential streams versus the parallel streams versus different implementations of completable futures, you'll see that the completable futures variants will always work better than the ones that use parallel streams. And certainly, of course, always run better than the things that use sequential streams if you have lots of cores. So your mileage may vary, but I think you'll typically find these results are borne out in practice. If you want to set up benchmarking, you might use the Java micro benchmark harness, JMH, which is a very cool capability. Another thing to keep in mind in terms of benefits of completable futures is combining them with sequential streams is often a win, as we showed with the image stream gang app. So when you do things like this, you can use streams to guide the overall flow of control of the application, kind of like we see here with these various fluent, intermediate, and terminal operations. And then we can use completable futures to perform asynchronous operations efficiently and scalably in parallel in different types of thread pools. So you're kind of getting the best of both worlds. We'll see that there's other ways to get the best of both worlds that are even more integrated into a framework, namely the reactive streams framework as provided by RxJava or Project Reactor. But if you're stuck with using the standard versions of this stuff that come out of the box with Java, then combining sequential streams and completable futures is actually very powerful. However, combining parallel streams and completable futures is most likely going to be overkill. This is a funny meme that says it's got a van with like 200 seatbelts in the back, and it says, overkill, why have one when you can have 200? So obviously it doesn't really help you to have 200 seatbelts. It's not going to make your car or your van any safer. And the same thing is true, of course, with having too much parallelism. So that's the overview of the pros. And I think you'll see that there are lots of advantages to using completable futures in practice. But of course, we have to look at the cons as well, which we're going to do next.